Welcome guys, this is VT engineering tutorial, and today we'll be looking at what deflection of beam, which we are going to be using what double integration method. And you know that we have different methods in which we use to analyze deflection of beam. We have Macaulay's method, we have moment area method, but today we'll be looking at what double integration method. And today I'll be teaching you what case 1, which is what a simply supported beam with a point load W at the center of what of the beam. If you look at the diagram, you can see that this is what a simply supported beam. I've already explained what is called a simply supported beam and different type of beam in our previous video. But in this case, we have what a simply supported beam with W what at the middle of what of the beam. And in this case, what we are looking here is what the beam is in length L. We have what length L. That is the length of our beam. So in this case, we want to calculate what deflection for this beam. And before we calculate deflection for a simply supported beam or a propped beam, we need to calculate what reaction at the support. So for this beam to be in stable equilibrium. And I hope you understand what I mean by reaction at the support. That we have already proved that in our previous video. So for me to calculate deflection of this beam AB, so I'm going to have reaction at what A, which is what my RA and what my RB. So in this case now, so before calculating deflection for this beam now, you know that the maximum deflection of this beam will occurs what at the middle. You understand? Because this is where the load is placed, and the effect of the load is more felt at this middle. So when beam is under a loading condition and deflects, this beam will deflect in a manner and way like this. We are going to have something like this when this beam is deflects. So this is how we are going to have deflection of this beam. So and the load is acting at the center. So load is acting at the center, that is this place is length over 2 and this place is length over 2, which is is acting at the center and divide the distance into 2 equal parts. So now let's go. For me to calculate reaction at point A and at point B. So you can take your reaction at point A or at point B. So the first thing you do is that you find your vertical upward force, which is summation of upward force must be equal to summation of downward force. So in this case now, for me to calculate reaction at A and B now, I'm going to have my RA and RB to be equal to W. Then next I'm going to find my moment to look for RA or RB. So in this case now, I'm going to have RA plus RB equals to W. Let me call this one my equation 1. So this means that summation of upward force, these are my upward forces, RA and RB, must be equal to downward force for this beam to be in equilibrium. So the next thing is to look for my moment. So by looking for my moment, I can decide to take my moment at point A. You understand? And you can decide to take my moment at point B. So if I'm taking my moment at point B, it means that summation of all forces in point A will be equal to 0. So therefore I'm going to have summation of moment at point A will be equals to 0. You understand? That is, at this point I'm having 0. Yes. Therefore I'm remaining with RB and W. So and we know from the definition of moment that moment is force times perpendicular distance. So in this case now, for me to have my moment to be summation of force here to be equals to 0, therefore I have RB and W. So my RB will cover capital letter L distance, because that's the total length of the beam, which is RB multiplied by L. So I'm going to have RB multiplied by L, that is RBL. But don't forget, I'm using coordinates, and you can decide to use clockwise and anti-clockwise movement. This is what I'm trying to use. My upward force should carry positive, and my downward force should carry negative. So in this case now, my RB is upward force, is carrying positive, and it's multiplying L distance, because that is total length before it reach A. So now I have a downward force, which is W, and W is coming in this way and is covering L over 2 distance. So negative W multiplied by L over 2 equals to 0, because summation of my moment is to be equals to 0. So in this case now, I have RBL equals to, this one will come to the other side and become positive, WL over 2. So for me to find my RB now, I'm going to divide both sides by L over 2. Therefore RB equals to WL over 2 divided by L. You understand? So in this case now, my RB equals to what? WL over 2 divided by 1 over L. L will cancel L. Then my RB is going to be what? W over 2. So this is value of my RB. So in this case, my RB is what? W over 2. This is what? This is the force that is countering this weight at this what? At this support. So in this case now, since I know the value of my RB, I can decide to take my moments at RB to find the value of my RA. But since I've already established my equation that RA plus RB must be equal to what? W. So in this case now, I can use this equation to find the value of my what? RA, which I'm going to have what? RA plus RB equals to W from equation what? Equation 1. So in this case, I know the value of my RB to be what? W over 2. That is RA plus W over 2 equals to what? W. So in this case now, my RA is going to be what? W minus W over 2. And you know that W over 2 is what? Half of W. You understand? And this is what? A OW. So by removing half from the whole, it's going to give me what? Half. So in this case now, my RA is going to give me what? W over 2. This is the value of my what? RA. That is the reaction and the support is what? W over 2. So I find the reaction at both the support. So the next thing for me is what? To section any part of this beam. You understand? I need to section only part of this beam to calculate deflection at what? Any section of the beam. So assuming that I'm sectioning this part, let me section here. This is what? My section XX. Sorry. So now, considering this section now, section XX, you can decide to section here, you can decide to section here, you can decide to section here, it's all the same. So, but considering this section now at a distance X from B, you know, this is another end, B, you understand? Considering this section now at a distance X from B, so I need to calculate with what? With my section SS now. So now, considering XX at a distance X from B, I've told you that moment is what? Force times perpendicular distance. So now I'm considering this section now at a distance what? X from B. So I need to find moments at this point now. So for me finding my moment at this point, so moment at X. So I'm going to have what? Moment at X. That is what? Moment at this section. So in this case now, I only have one force here, which is what? My RB. You understand? Which is what? Upward force, which I've already given what? Positive. You understand? That is what? RB, and the distance covered is what? X. So I'm going to have what? RB multiplied by what? X. So this is my moment at what? Section XX. So in this case now, don't forget that the value of my RB is what? W over 2. So I'm going to have equals to what? W over 2 multiplied by what? X. You understand? This is going to be what? My moment at section XX. But recall, so now, but recall that M moment equal to what? EIG square y over dx square. This one has already been established in what? In relationship between slope, deflection, and radius of curvature. Since moment equal to EIG square y over dx square and moment equal to W over 2x, definitely this one is equal to this one. And I'm going to have what? EI, therefore, the square y over the x square equals to what? W over 2x. Let me call this one my what? My equation 2. So now, according to this method now, what you are trying to do is that we use double integration method in finding what? Slope equation, maximum slope equation, deflection equation, maximum deflection of this beam. You understand? So for us now to find our slope equation, because that's what we are going to do first, we need to integrate this equation number 2. So by integrating this equation number 2 now, we are going to have what? So now, by integrating equation 2 now, we are going to have what? EI dy over dx. You understand? Because if I integrate this equation, I'm going to have this. Because this is what? The second order of what? Differentiation equals to what? W over 2. Don't forget that x is what? My variable here. So by integrating x, there is an invisible one here. By integrating, I'm going to have what? X squared over what? 2. So plus what? C1 So as you can see that I've already integrated this one, and in this case now I'm integrating with what? With respect to s, in which what? EI is a constant and W over 2 is what? A constant. So with respect to x, don't forget, with respect to x, I'm integrating with what? With respect to x. So in this case now, for me to simplify this one now, I'm going to have EI dy dx equals to what? This is a multiplication. I'm going to have WL squared over what? Over 4 plus C1. So let me call this one my what? My equation what? 3. And equation 3 is what? So my C1 now, the first constant of integration obtained what? At x equal to L over 2 and dy dx equals to 0. If you look at this diagram, you can see that I obtain my C1 at this point, because this is the point of what? X equals what? L over 2 and dy dx equals to 0. At this point, I'm going to have my what? My dy dx to be what? To be 0. So now, this one is what? A, and this one is what? B. So in this case now, what I'm trying to do is that whenever I see x in this equation, I'm going to put L over 2. You understand? So I'm going to have the value for my what? For my C1. So by doing so now, I'm going to have what? EI dy dx equals to what? So now in this case now, I know that my x is what? L over 2. So W into bracket L over 2 square over 4, then plus what? Plus C1. So I'm trying to find what? For the value of my C1. So but don't forget that my dy dx is also equal to what? 0. Definitely this one is equal to what? 0 equals to what? So now W, I'm going to have what? L square here. 2 square is what? 4. 4 multiplied by 4 is what? 16 plus what? C1 now. So for me to get the value of my C1, so this one just need to come to the other side. So I will be left with what? C1. Definitely my C1 is going to be what? Minus WL square over what? Over 16. So this is the value of my what? Of my C1. So the next thing for me to do is what? To substitute the value of my C1 into this equation 3. You understand? When I substitute the value of my C1 into this equation, I'm going to have what? Equation for slope at any section of what? Of this beam. So that's what I'm going to do next. So if I substitute this value into this equation now, I'm going to left with what? EI dy dx equals to what? Wx squared over what? Over 4. So the value of my C1 now is what? Minus WL squared over 16. Minus WL squared over 16. So this equation now. So this is the required equation. Equation for what? For slope at any section of the beam. So for me to have my maximum slope, where am I going to have my maximum slope? Look at this diagram. For me to have my maximum slope, I'm going to have my maximum slope at this point and what? At this point. This is where I'm going to have what? My maximum slope. So equation for calculating what? For my maximum slope is going to be what? So I'm going to have what? Maximum slope my maximum slope occurs at what? A and B when x is equal to 0 and y equal to 0. For me to have my maximum slope at this point, you understand? At this point, point A and point what? Point B. At this point, my x is equal to 0 and my y equals to 0. At this point, my x is equal to 0 and my y is equal to what? 0. So in this case now, anywhere I see x, I put 0. Anywhere I see y, I put 0. So in this case now, I'm going to, here is what? I'm going to still have what? EI dy over dx equals to what? So in this case now, my x equal to 0. Definitely all this one will be what? 0. Then I have what? 0 minus what? WL square over 16. Definitely I'm going to have what? EI dy over dx equals to what? Minus WL square over what? Over 16. But I'm looking for slope, and you know that slope is what? Dy over dx. So what I'm going to do next is what? To divide both sides by what? EI. Don't forget that EI is what? A constant here, which is what? Our flexural rigidity. EI is what? Flexural rigidity. So my dy dx now, by dividing both sides by EI, you understand? I'm going to have what? Minus WL square over what? 16EI. You understand? So assuming that I'm taking my slope from B, you understand now? So since I know that dy dx equal to minus WL square over 16EI, but don't forget that my sectioning is from B. So this one is from what? From B. So assuming my dy dx now, let me just dy dx equals to what? Let me do it like this. That is what? From B. You understand that I'm going to have what? Negative WL square over what? 16EI. So now, in this case, this is from B. So by symmetry, by symmetry now, since this is from what? From B. So for me to have my slope at what? At point A. You know that our maximum slope occurs at what? A and B. So now my dy dx for A now, dy dx equals to what? WL square over what? Over 16EI. This one is going to carry what? Positive. So this equation now is the equation for what? Maximum slope at what? At any section of the beam, which was at point A and B. So the next thing for us is to do what? Is to find what? Is to find our equation for what? For deflection, and to find at which point we are going to have what? Our maximum deflection. So I hope you understand and I hope you are following. It's very, very simple. You can learn it. You just need to understand and you'll be following. So you know, this method is what? Double integration. The first integration that we do here is what? To get our slope, equation for slope, you understand, and to have equation for what? Maximum slope. So the next integration that we are going to do now, we are going to have what? Our equation for deflection and what? An equation for what? Maximum deflection. So now by integrating that equation for slope now, that is what? By integration equation for slope now, integrating for slope with respect to x, which is what? This one now, we are going to have what? EI dy over dx equals to what? When you integrate wx square over 4, you know that our power there is what? Square. You understand? We are going to add 1 to it, then multiply it by what? By the denominator. Then we are going to have what? Wx cube over what? Over 12. Because 3 times what? 3 times 4 is going to give us 12. Then we still have minus wl square. But in this case, don't forget that we are integrating what? With respect to x. And in this case, we don't have x. Definitely, all this one is what? A constant. So by integrating constant, we are going to have what? A variable. So in this case now, we are going to have what? X here, and definitely over what? Over c. So plus c2. So let's call this one what? Our equation what? Our equation 4. But in this case, this one, when I integrate dy dx, is going to give me what? Y. It is a mistake, sorry guys. So in this case now, we have established our what? Another equation. So what we are going to do next is what? To find the value for our c2. Then substitute it back into what? Into this equation. So for me to find the value of my c2 now, what I'm going to do to find the value of my c2 now is that, so the value of my c2 is what? Second constant of integration, which is what? c2 equals to what? So my c2 now, the value of my c2, second constant of integration, is obtained at x equal to 0, y equal to 0. So my c2 is obtained at what? At this point. You understand? Either A or B. You understand? At this point, x equal to 0, then y equal to 0. So definitely, if I substitute x equal to 0 and y equal to 0 into this equation, what am I going to have? Here I'm going to have 0 because y is equal to 0. Here I'm going to have 0 because x equal to 0. You understand? Then here I'm going to have 0 because what? X equal to 0. So I'm left with what? C2. Definitely C2 will be equals to what? 0. I hope you understand. X equal to 0, y equal to 0. Definitely all this equation is what? 0. You understand? So the next thing for me is what? To write the equation, since my C2 is what? 0. So I'm going to have what? Definitely I'm going to have what? EIY equals to what? WX square over 12 minus WL square x over 16. So plus is 0. You know that my c2 is equal to 0. So this is what I'm left of. So this is what my equation. Let me call this one my what? My equation what? Equation 5. So yes, I hope you understand and I hope you are following. So my equation 5 now is what? The required equation for deflection at any section of what? Of this beam. So this equation now is what? Required equation for what? For deflection at what? At any section of this beam. So the next thing for me is what? To find my what? At where am I going to have what? My maximum deflection. So if you look at this diagram very well, you can see that my maximum deflection is going to occur at what? At the middle, because this is where the load is placed, and this is where the effect of the load is felt most. So at this point now, this is going to be my what? My maximum deflection. So my maximum, for me to have my maximum deflection is when what? When the section x is what? Is what? L over 2. You understand? Because this distance from B, you know that I'm considering this section from B. This distance from B is what? L over 2. From this point to this point is what? L over 2. You understand? So when the section XX has covered L over 2, I'm going to have what? My maximum deflection. So in this case now, maximum deflection. Maximum deflection occurs at what? At midpoint when x equals to what? L over 2. So what I'm going to do is that anywhere I see x, I will just substitute what? L over 2 in this equation. So in this case now, I'm going to have what? EIY equals to what? So now I have WL square over 12, and I know that my x is what? L over 2. So I'm going to have what? WL over 2 square over what? Over 12 minus I have WL square x, which is what? L over 2 over 16. That is what? WL square L over 2 over what? Over 16. So I think this is what I'm left with. So the next thing for me is what? To simplify this equation. So by simplifying, I'm going to be left with what? EIY. In this case, this one is what? L square. I'm going to have what? WL square. This one is what? 2 square. You understand? Then this is going to multiply your what? Your denominator. So I'm going to have what? 2 square is what? 4. You understand? 2 square is what? 4. Then 4 times 12. What are we going to have? Is what? 48. We are going to have 48 here. This is the negative. You understand? This one is what? WL square. You understand? So sorry guys, that place is a mistake. You're supposed to have what? L cube here, because since we have integrated from this place, our power is what? Cube, and in this case is what? Cube, and anywhere we see x, we are going to represent it with what? L over 2. You understand? So now when we represent it with what? L over 2, we are going to have what? WL. In this case, we are going to have WL cube, and now we are having 2 cube, and 2 cube is what? 2 times 2 times 2, which is what? 8. 8 multiplied by 12 is what? 96. You understand? So in this case now, we have WL square multiplied by L is what? WL cube over what? This one is 2. 2 multiplied by 16 is what? 32. I hope you understand, and I hope you are following. It's very, very simple. So in this case now, we need to simplify this now. If we simplify this, we are going to have what? LCM of what? Of 96. Then 96 in 96 is what? 1. Then 1 multiplied by WL cube, in this case, we are going to have what? WL cube minus what? 32 in what? In 96. You understand? It's going to give us 3. Then 3 multiplied by WL cube is what? 3 WL cube. So in this case now, we have negative 3L cube and what? WL cube. So in this case now, we are going to have what? Minus 2WL cube over what? Over 96. So 2L1, 2 here is what? 48. So now our EIY, therefore, our EIY is equal to what? Minus WL cube over what? Over 48. But don't forget that our y is used to denote what? Deflection. And since the y dx is what? Slope, our y is what? Our deflection, because this is what? The second order of what? Integration. So for me to get the value of my y now is to divide both sides by what? By EI. So for me to eliminate EI now, I divide both sides by what? By EI. So I will be left with what? Y here. You understand? Let me just write y maximum, because at this point, this is where I'm having my what? My maximum my maximum deflection. So in this case now, my y maximum is going to be what? Minus WL cube over what? 48 EI. So this equation now is the equation for what? Maximum deflection at this section of what? Of the beam. So this one is what? Equation to understand, and I think if you practice it very well, you will understand very more. So please, thank you for watching our video, and please subscribe to this channel and reverse us to your friend who might be in need of this. Thank you very much.